Hi, I am Lopamudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. Welcome back to my channel with a new lecture series on VLSI technology, that is epitaxy. It is very much important topic for you guys, those who are trying to crack NTA UGC NET exam for electronic science. And also it is very important topic for West Bengal SET exam. In Unit 2 of the electronic science syllabus, this topic is placed. In previous class, we discuss about the introduction part and the basic fundamental of the epitaxy process. Today I will discuss the types of epitaxy and the various grown technique of epitaxy process. Okay, so let's start our class. First we discuss the type of epitaxy. So epitaxy means to grow the crystalline layer on top of a bulk crystalline layer. Right? What are the restrictions? Can I grow anything on anything? This thought brings us the types of epitaxy. First one is Homo epitaxy and the second one is Hetero Epitaxy. When I say Homo epitaxy, it means the same material is grown over the bulk crystal. That is, if we can consider that I have a silicon bulk crystal and I want to grow a silicon layer on top of that, it is possible, right? It may be a different doping concentration of a different resistivity, but the bulk crystalline material and the epitaxial layer material is same, right? So if we consider one example, that is bipolar junction transistor, right? We had a p-type silicon substrate. On top of this we grew an n-type epitaxial layer, but both of them are made of silicon material, so the material is same. So this is an example of Homo epitaxy. Okay. In contrast, if I have a certain crystal as the substrate or as the bulk material and I want to grow something else on top of that, that is, if I have two dissimilar material, that is the epitaxial layer material is dissimilar from the bulk material, then it is called heteroepitaxy. A very common example is silicon on sapphire, that is SOS. Sapphire is actually nothing but aluminum oxide. It has a hexagonal lattice pattern, and silicon, as we know, it has a diamond lattice pattern. So two dissimilar material we want to grow one on top of other. So heteroepitaxy is much more complicated than Homo epitaxy, right? The three important rules that are observed during the heteroepitaxy. The first one is, in heteroepitaxy is possible if there are no chemical reaction between the substrate material and the epitaxial layer. The second rule is, there should be no lattice mismatch between the substrate material and the epitaxial layer. And the third rule is there should be no thermal mismatch between the two material. That means between the substrate material and the epitaxial layer material. But only the first rule, that is no chemical reaction between the substrate material and the epitaxial layer, is very stringent. If there is a chemical reaction occur between the two materials, we cannot have an epitaxy. Okay. Lattice mismatch we can tolerate up to a certain level. I told you already that sapphire and silicon, there is no lattice matching, right? Sapphire, that means aluminum oxide, which is a hexagonal crystal lattice pattern, and silicon, which is a diamond crystal lattice structure. So there is no lattice matching, but it can be grow, and the problem is the thickness of the epitaxial layer. Okay. When there is a lattice mismatch occur, a lot of strain in the epitaxial layer will be appear, right? So up to a certain thickness, if you are growing very thin layer, this strain can be taken, or we can stay with the strain can be tolerated. Okay. Beyond this, it is not allowed. So the strained layer epitaxy is very important topic in today's research area. So hetero epitaxial layer is very much useful for compound semiconductor. Okay. Epitaxy system can be classified as liquid phase epitaxy, second one is vapor phase epitaxy, and the third one is molecular beam epitaxy. In the vapor phase epitaxy and the liquid phase epitaxy, there are some chemical reactions involved. In contrast, in molecular beam epitaxy, there is no chemical reaction involved. This molecular beam epitaxy technique is a physical evaporation process. It is very complicated as well as very sophisticated system. Okay. Liquid phase epitaxy does not have much use. So silicon epitaxy is grown either vapor phase epitaxy or molecular beam epitaxy. Liquid phase epitaxy means it is done in liquid phase. So in liquid phase epitaxy process, you can consider some solution, right? But in vapor phase epitaxy, as the name itself suggests, that the material transport must be in form of vapor. So you have to use gas reactants. So there is some chemical reaction involved. So you have to use some gas or a liquid with a very high vapor pressure, which can be vaporized very easily. So these are the epitaxy system. These three system is the classification of epitaxy system. Okay. I hope you understand. So here we end today's session. In next lecture, we talk about in detail about the vapor phase epitaxy process. Okay. With this, we have come to the end of this session. I hope you like this video. Thank you friends. If you like my video, please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.